We like to think of our planet as a finished map, a fully explored house where every room has been measured and every secret catalogued. But when we look at the vast, crushing weight of the Pacific Ocean, we realize that we are actually living on a giant mystery. Deep below the sun-drenched waves, there exists a vertical kingdom so hostile and alien that it challenges the very definition of what life is. This is the Mariana Trench, a crescent-shaped scar in the Earth's crust that drops over 11 kilometers into the cold, silent heart of the world. For centuries, we assumed that this was a wasteland of absolute stillness, a place where the physical laws of biology simply reached their limit. We believed the pressure would snap bone like glass and the freezing temperatures would bring the machinery of the living cell to a standstill. Yet, every time we send a tiny, glowing eye into that darkness, we find that nature has found a way to thrive in our absence. These discoveries raise an unsettling question. If life can exist there, what else might be hiding in the parts of Earth we cannot reach? Human history is filled with legends of leviathans and sea monsters, stories born from the fear of a horizon that never ends and depths we cannot see. For the sailors of the HMS Challenger in 1875, these were not just stories, but a constant, gnawing dread as they peered over the railing. They were the first to drop a weighted line into this specific abyss, watching kilometer after kilometer of wet rope disappear into the blue void. When the weight finally hit the bottom at 8,000 meters, it didn't just measure depth, it shattered our understanding of the planet's scale. Since that day, the Mariana Trench has become a mirror for our own curiosity, reflecting both our technological triumphs and our profound biological limitations. To understand why we are so obsessed with this trench, we have to look at the psychology of the unknown and the thrill of the impossible. We are a species of builders and light bringers, yet we are drawn to the places where our light fails and our structures are easily crushed. The trench represents the ultimate elsewhere, a frontier that is closer to us than the moon, yet arguably more difficult for us to inhabit. In this environment, the weight of the water above is equivalent to having an elephant standing on your thumbnail for every square centimeter of skin. Modern science tells us that nothing with a hollow lung or a fragile shell should be able to survive such a relentless, heavy embrace. But as we began to explore the Haddle Zone, we realized that the rules of life were actually just suggestions that evolution had learned to ignore. Join us as we dive past the limits of the sun to discover how the Earth recycles its own crust and hides its strangest inhabitants. To understand the trench, we must first look at the ground beneath our feet, which isn't as solid as it seems. Our planet's outer shell is cracked into massive tectonic plates that float like giant rafts on a sea of molten magma. While the continents are thick and buoyant, the ocean floor is thin, dense, and constantly on the move across the globe. In the Atlantic, plates are pulling apart, creating new Earth. But in the Pacific, the story is one of violent destruction. This is the Ring of Fire, a 40,000-kilometer fracture, where plates collide and grind each other into dust and liquid rock. Here, the ancient Pacific Plate, cold and heavy after millions of years, meets the younger, lighter Philippine Plate in a silent struggle. Gravity wins the battle, pulling the edge of the Pacific Plate downward, forcing it to slide deep into the Earth's burning mantle. This process, called subduction, creates a massive V-shaped valley that we recognize as the deepest canyon on our planetary home. As the rock is forced down, it bends and snaps, triggering 90% of all earthquakes that rattle our surface world. This is the Earth's great recycling program, where old crust is melted down to be reborn as volcanic fire and new islands. But the Mariana Trench isn't just a geological graveyard. It is also a chemical laboratory of the most extreme kind. Around the fault lines, we find mud volcanoes that spew hydrogen and strange vents that leak liquid carbon dioxide into the sea. At these depths, the pressure is so high that gases behave like liquids, creating pools of molten sulfur found nowhere else on Earth. These vents act like chimneys for the inner Earth, releasing boiling, mineral-rich water that would be toxic to almost any surface creature. For a long time, we thought these hot, acidic springs were the end of the line for any hope of biological survival. Yet, it is precisely in these chemical clouds that scientists believe the very first sparks of life on Earth may have ignited. If life began in these dark, crushing depths, then the creatures living there today aren't just outliers, they are our oldest relatives. They have spent billions of years perfecting the art of survival in a world that hasn't changed since the dawn of time. To find them, we must leave the light behind and descend through the layers of the ocean where the sun slowly dies. Our journey starts in the epipelagic zone, a thin blue ribbon of light that holds the key to all life on the planet. The first 200 meters of the ocean are a bustling metropolis fueled by the pure energy of the sun. Here, microscopic phytoplankton perform the miracle of photosynthesis, creating half of the oxygen every human on Earth breathes. It is the foundation of the global food web, where tiny drifters feed the giants of the open sea. But as we sink further, the bright turquoise fades into a ghostly indigo, marking our entry into the twilight zone. Between 200 and 1,000 meters, the light is too weak for plants to grow, but the water teems with life. This is the mesopelagic, a realm of shadows where creatures have evolved biological lanterns to communicate and hunt. We see the first flashes of bioluminescence, an eerie blue glow that travels further through water than any other color. In this dim world, the bristlemouth fish reigns supreme, possibly the most numerous vertebrate on the entire planet. Billions of these tiny hunters migrate vertically every night, a massive biological wave moving toward the surface to feed. But soon, the last faint photon of sunlight vanishes, and we enter the eternal night of the bathypelagic zone. 1 kilometer down, the temperature drops to a steady 4 degrees Celsius, and the pressure begins to feel lethal. The midnight zone covers more than half of our planet's surface, yet it remains more mysterious than the moon. Here, animals like the barrel-eye fish have developed transparent heads and upward-pointing eyes to scan for silhouettes above. Others, like the small-eye snipe eel, have abandoned sight entirely, relying on delicate pressure sensors to feel their surroundings. Without sunlight, the only source of food is marine snow, a constant drizzle of organic debris falling from the world above. It is a slow-motion rain of dead plankton, fish scales, and waste, sustaining a kingdom of patient, slow-moving scavengers. Because meals are so rare, evolution favors the strange, creatures with expandable stomachs and jaws that can swallow anything. The pelican eel is a living nightmare of efficiency, capable of unfolding its massive mouth to consume prey larger than itself. At these depths, we also encounter deep-sea gigantism, where lack of predators and cold temperatures allow species to grow enormous. Giant squids, with eyes the size of basketballs, glide through the dark, hunting in a world where we are the intruders. As we leave the midnight zone, we cross the threshold into the deepest part of our planet, the Hadal zone. Named after the Greek god of the underworld, this region begins at 6,000 meters and descends into the abyss. At these depths, the weight of the water above is so great that it actually compresses the molecules of the water itself. For decades, biologists theorized that life here was impossible because the pressure would crush the proteins that build a body. But in 1960, two men inside a steel sphere called the Trieste proved the entire world wrong. Don Walsh and Jacques Picard sat in a tiny cabin, descending for 5 hours into the heart of the Challenger Deep. Near the bottom, a loud bang echoed through their vessel as a window cracked under the relentless squeezing of the ocean. They didn't turn back. They kept going until they reached the very floor of the world, 11 kilometers down. Through a tiny port, they saw a flatfish-like creature resting on the silt, a ghost in a world of shadows. This single observation changed everything, proving that the Hadal zone was not a tomb, but a home for the resilient. We now know that life here uses a special molecule called TMAO to keep their proteins from collapsing under pressure. It is a chemical armor that allows the Mariana snailfish to swim gracefully, where a human would be flattened instantly. These snailfish are pink, translucent, and lack scales, looking more like a piece of tissue than a top-tier predator. Yet, they are the kings of the trench, hunting small crustaceans in a place where no other fish can follow. Below 8,000 meters, even the snailfish disappear, leaving the world to the smallest and strangest organisms of all. Here we find xenophyrophores, giant, single-celled organisms that grow to the size of a dinner plate. Imagine a single cell, usually microscopic, expanding until it is a complex, branched structure you can hold in your hand. They are living puzzles that defy our understanding of how a cell manages its internal machinery at such a scale. These giants act as host structures, providing a surface for even smaller microbes to build a microscopic ecosystem in the silt. In the deepest pockets of the trench, we find a world that feels more like another planet than our own Earth. Exploring these depths is not just about cataloging strange fish, it is a journey into the mechanics of our planet. The Mariana Trench is part of a global network of chasms that act like the seams on a giant, rocky baseball. These rifts are where the Earth's engine is most visible, revealing how the cooling crust drives the movement of continents. To understand this, we must look at the Atlantic, where the mid-ocean ridge is pushing the Americas away from Europe. While the Atlantic grows, the Pacific must shrink, being devoured by the very trenches we are currently exploring today. The tectonic plate entering our trench is 170 million years old, the oldest seafloor on the planet. It has traveled across the entire ocean like a geological conveyor belt, collecting the history of the Earth in its silt. Now it is reaching the end of its life, being dragged down into the furnace of the mantle to be recycled. This subduction doesn't just swallow rock, it also drags down vast amounts of water and carbon deep into the Earth. Without this process, our atmosphere would be choked with CO2, and the Earth would likely become a scorched greenhouse world. The trench is a vital organ in the Earth's climate system, regulating the chemicals that allow life to exist above. But as we look closer at this pristine frontier, we are finding disturbing evidence of our own far-reaching influence. In recent dives, researchers found plastic bags and candy wrappers at the very bottom of the Challenger Deep. Even in a place so remote that only a handful of humans have ever seen it, our trash arrived before we did. Chemicals like PCBs, banned decades ago, have been found in the fatty tissues of amphipods living 10 kilometers down. This reveals a sobering truth. There is no away on our planet. Everything we produce eventually finds its way home. We used to think of the ocean as an infinite sink, a place large enough to hide any mistake we made. But the trench shows us that the deep ocean is actually a funnel, concentrating our impact into its deepest pockets. This discovery shifts the mystery from what lives there to how can we protect a place we barely understand. The deeper we go, the more we realize that the trench is not a separate world, but part of our own. As we reach the absolute bottom of our journey, we find ourselves standing in the most exclusive place on the planet. Only a small group of explorers has ever witnessed the Challenger Deep in person, a number recently surpassing lunar astronauts. One of these pioneers was filmmaker James Cameron, who in 2012 became the first person to make a solo descent. He spent years engineering a vertical torpedo-shaped craft capable of surviving the crushing weight of 7 miles of water. For hours, he sat in a cramped metal sphere, watching the light disappear as he entered the most remote wilderness imaginable. When he finally touched down, he described the landscape as a lunar-like plain, desolate and completely isolated from the world. This isolation is what makes the trench so valuable to science. It is a time capsule of the early Earth. However, the history of deep-sea exploration is also a history of immense risk and the limits of human engineering. In 2014, the unmanned probe Nereus suffered a catastrophic implosion, turning a sophisticated robot into dust in a millisecond. The pressure is so unforgiving that a microscopic flaw in a hull can lead to a collapse faster than the human brain can process. These tragedies remind us that the trench is not just a place to visit, but a force to be respected. Yet, despite the danger, we are driven to return by a fundamental human need to see what lies in the dark. Beyond the physical pressure, there is the biological mystery of how life thrives without the primary energy source of the sun. We mentioned chemosynthesis earlier, but the scale of this alternative energy system is only now being fully realized by biologists. In the absence of light, bacteria harvest energy from the Earth itself, breaking down minerals to build the molecules of life. This means that life on Earth is not entirely dependent on the sun, a fact that changes our search for life elsewhere. If the Mariana Trench can support a thriving ecosystem, then the icy moons of Jupiter and Saturn might as well. Beneath the frozen crust of Europa or Enceladus, there are deep oceans potentially warmed by similar volcanic and tectonic forces. The trench serves as our training ground, a laboratory for understanding how life might survive in the cold oceans of space. Every snailfish we find and every microbe we study brings us closer to answering if we are alone in the universe. While we dream of alien oceans, we often forget that the Mariana Trench is an alien world right here on our doorstep. Most of what we know comes from rare specimens brought up by remote probes or creatures occasionally caught by deep-sea fishing. When these animals are removed from their high-pressure home, they often undergo a tragic and violent transformation. Without the weight of the ocean to hold them together, their cells expand and their bodies distort beyond recognition. A creature that looks like a graceful ghost in the deep can become a shapeless, melted mass on the deck of a ship. This means our initial understanding of deep-sea life was based on broken remains, like trying to study birds from fallen feathers. We are only now beginning to see them as they truly are, thanks to high-definition cameras that can withstand the abyss. These cameras reveal a world of delicate beauty, where translucent fins pulse like silk in the beam of a robotic light. But even with our best technology, the vast expanse of the trench floor remains the last unexplored frontier on our planet. Just the Challenger Deep alone, a tiny portion of the whole trench, is large enough to swallow 5 Grand Canyons. To explore it all would take centuries, yet we are changing the chemistry of these waters in just a few decades. The trench is not just a sink for our trash, but a sensitive indicator of the health of our entire global ocean system. Every time we burn fossil fuels or dump plastic, a chemical signal eventually reaches the deepest valley on Earth. This connectivity is a reminder that the underworld is not a separate room, but the foundation of our shared home. Scientists are now rushing to map the seafloor in high detail, hoping to find secrets before they are lost to human impact. They are finding massive underwater mountains and hidden canyons that have never seen a single photon of light. Some of these features are so large, they influence the very currents that regulate our weather and provide our food. The deep ocean acts as a giant heat sink, absorbing the excess energy from our warming atmosphere and protecting us. But like a sponge, it has a limit, and we don't know what happens when the deepest parts of the ocean begin to warm. As the temperature of the Hadal Zone shifts, the delicate balance of life there may face its first crisis in millions of years. If the trench is a mirror of our impact, it is also a reminder of the sheer resilience of life against all odds. Even as we struggle to reach it, life there has spent millions of years solving problems we are only just beginning to name. For instance, the way these creatures handle extreme cold and pressure could lead to breakthroughs in how we preserve human organs. The enzymes found in deep-sea bacteria are already being used in laundry detergents that work in freezing water. We are mining the genetic code of the abyss for solutions to our problems in the world of light. But this raises an ethical question. Are we exploring the trench to learn from it, or simply to exploit it? As surface resources dwindle, some companies are already looking at the deep ocean floor as a source of precious metals. Potato-sized rocks called polymetallic nodules, rich in cobalt and nickel, sit undisturbed in the silt of the deep plains. These minerals are essential for the green energy transition, but harvesting them could destroy ecosystems we haven't even named yet. It is a classic human paradox. To save the atmosphere, we might have to sacrifice the last pristine place on Earth. The Mariana Trench sits at the center of this debate, a silent witness to our scramble for a sustainable future. To understand the stakes, we have to realize that the seafloor is not just mud, but a living, breathing skin. Bristleworms and small decapods tunnel through the sediment, recycling nutrients that keep the ocean's chemistry in balance. If we strip mine the deep, we risk clogging the very filters that keep our oceans and our planet habitable. The scale of the trench makes it feel invincible, but the biology within it is incredibly fragile and slow-growing. A deep-sea coral may take 1,000 years to grow just a few meters, making recovery from damage almost impossible. This slow pace of life is a reflection of the environment itself, where time seems to stretch and stall. In the Hadal Zone, the concept of a year has little meaning. There are no seasons, only the constant, heavy dark. It is a world of extreme patience, where a single meal might have to last for months of waiting. When we look at a snailfish, we aren't just looking at a fish, but at the ultimate survivor of a billion-year war. As we begin our long ascent back to the surface, the darkness of the Hadal Zone slowly gives way to the deep purple of the Midnight Zone. We leave behind the snailfish and the giant, single-celled organisms, returning to the realm of bioluminescent hunters and giant squids. The journey back feels like traveling through the history of life itself, moving from the most ancient, stable environments to the chaotic surface. We pass through the Twilight Zone, where the first faint rays of blue light begin to pierce the heavy, cold water. Finally, we break the surface, where the tropical sun of the Pacific Ocean blinds us with its intensity and warmth. Back on the deck of our ship, the Mariana Trench feels like a dream, a silent world that exists right beneath our feet. But the data we have collected tells a different story. A story of a planet that is far more connected than we ever imagined. We are the first generation to truly see the deep ocean, yet we are also the first to pose a serious threat to it. This brings us to a philosophical crossroads regarding our role as the dominant species on this watery blue marble. Are we merely curious observers, or are we the guardians of a wilderness that cannot speak for itself? The trench reminds us that we are small, and that our understanding of nature is still in its early, clumsy stages. It humbles us with its scale, showing us that even our greatest mountains are just pebbles in the face of the abyss. Yet, it also empowers us, proving that life can flourish in the most impossible conditions through the sheer power of evolution. This resilience should give us hope, but it should not be an excuse for our own recklessness or apathy. The secrets of the Mariana Trench are not just scientific curiosities, they are the blueprints for survival on a changing planet. By studying how life handles extreme pressure and chemical toxicity, we might find the keys to our own future resilience. But to do so, we must ensure that the trench remains a sanctuary for the strange and the beautiful. As we look out over the empty Pacific, we realize that the real mystery isn't what is hiding in the dark. The real mystery is whether we will have the wisdom to protect the things we haven't even discovered yet. The journey into the deep is far from over. In many ways, we are only just beginning to get our feet wet. Perhaps the greatest lesson of the Mariana Trench is that the impossible is simply a border we haven't crossed yet. It teaches us that life doesn't just endure, it innovates, finding energy in the very stones and pressure of the earth. If we can find beauty in a translucent snailfish or a giant single cell, we can find it anywhere in the cosmos. Our planet is a complex, breathing machine, and every gear from the highest peak to the deepest rift matters. We must decide if our legacy will be the trash at the bottom or the wisdom to leave the abyss untouched. The trench is calling to us, not as a resource to be consumed, but as a story to be understood and respected. Every time we look into the deep, we aren't just looking at the ocean, we are looking at our own origin. The journey to the Challenger Deep has shown us how far we can go when we combine curiosity with courage. But the true challenge is not reaching the bottom. It is living on the surface in a way that protects the bottom. As the sun sets over the Pacific, the trench remains in its eternal night, waiting for our next careful visit. We are a part of this world, from the oxygen we breathe to the tectonic plates that shift beneath our feet. There are no boundaries in nature, only connections that we are just beginning to map with our science and hearts. The Mariana Trench is a reminder that even in the darkest, coldest corners, the flame of life refuses to go out. It is a testament to the fact that we live on a planet of infinite wonder, if only we have the eyes to see. Our journey today ends here, but for the explorers and scientists of tomorrow, the real adventure is just beginning. Will we be the ones to solve the mysteries of the Hadal Zone, or will we leave them for a future generation? The answers are down there, buried in the silt and swimming in the dark, waiting for someone to find them. Until then, the trench will keep its secrets, guarded by the weight of 1,000 atmospheres and total silence. Thank you for joining us on this descent into the deepest hole on Earth. Stay curious and keep looking deeper. For in the end, the more we learn about the ocean, the more we learn about what it means to be human.